So we have seen how Kubernetes DNS works, and I have also shown you this demo. Now, one more thing I want to tell you is that can you use the service name from a node? So let's take a look at it. So let's say we have this master and worker one, and we have name server, and this name server caters to the nodes, not the pods. Now at the master node, suppose you submit these commands, either nslookup followed by the service name, or curl followed by service name dot namespace name dot svc dot cluster dot local. So what do you think could happen? Will you get a response? So think about it, pause this video and then come back when you are done. So I hope you got the answer. Now the answer would be no. It will give you an saying that the service name was not found, because what will happen, see, when you type this command, either nslookup followed by the service name or curl followed by the service name, it will go and check resolve.conf file. And resolve.conf file, it will see the name server is 169.254.169.254, which is this name server. I'll it will go to this name server and request the IP address of the service name. But this name server does not have any information about the service name that you have typed, because the scope of the service name is within the Kubernetes world and within the pods. So this name server does not have any information whatsoever about the service name. So it will return that it did not find any IP address. So any one of these commands will error out. Now let's say we have these pods and also this another pod in the master node, which is a core DNS pod. And this is the name server for pods. So now we are getting into the Kubernetes world. Now this core DNS pod will have this entry of service name followed by the IP address. The IP address is nothing but the cluster IP address, and the actual entry would be in the IP tables. So now when you run the same command, so this cmd is nothing but this same command. Now when you run this command from any one of the pods, what will happen is that it will go and check the resolve.conf file in the pod itself. It can be any pod, either this pod or this pod, does not matter. Every pod has the same hc resolve.conf file. So it will go to resolve.conf file, and then it will get the IP address of the name server. Now IP address of the name server is actually the cluster IP of the service that was created for core DNS pods. So it will go and hit the core DNS pod, and then it will get the IP address, the cluster IP of the service name, and the request of this command will be satisfied because the service has been created and there's an entry in the core DNS name server. So if you're trying to access the service from the node, it will not work. But if you use the IP address directly, it will work, because when you use the IP address, it will go and check the IP tables. But when you use the service name, it has to get the IP address. And for that IP address, it should make a contact with kubedns server or kubedns pod, which is beyond the scope of the node. So that's why when you use IP address, it will work, but when you use the service name, it will not work. So what we have discussed so many things. We have just covered 7 sections, but still a lot of things have been discussed. So let's look at them one by one. The first thing that we discussed was Kubernetes cluster, and we used kubeadm to create a Kubernetes cluster. But we should not use it. We use any one of the cloud service providers, either AWS or Azure or Google Cloud. So using the cloud service provider, we should create a Kubernetes cluster. Then we have also seen API server, scheduler, controller. These 3 components are there in the master node. These components also run as pods in the master node, which you have also seen. Then there are Kubernetes objects like labels and selectors, pods, replica sets, replication controllers, deployments, namespaces, Kubernetes DNS. So you know what a pod is. The replica sets is nothing but running a certain number of pods at any point in time. Deployment is actually used on top of replica set. So when you create a deployment, it creates a replica set for us automatically, and then it launches the pods. The advantage of deployment is that we can have rolling upgrade. Then we talked about namespaces, which are nothing but logical grouping of Kubernetes objects. So we can have multiple namespaces. And then finally we saw services and DNS. You use service to expose the application to outside world. And there are three types of services: node port, cluster IP, and load balancer. We have not discussed load balancer yet because that will be done by, or that will be provided by cloud service provider. And finally, we had seen Kubernetes DNS, which is implemented by core DNS in Kubernetes, and core DNS also runs as pods in the master node. Then also we saw pod networking. I had showed you WeaveNet and Flannel. We have not used Calico yet. It should be WeaveNet, not WeaveNerd. Now you should use either WeaveNet or Calico. Abstain from using Flannel because Flannel does not give you a lot of features and functionalities. WeaveNet and Calico does. When you use cloud service provider, either AWS or Google Cloud, both of them use Calico. So we'll see Calico later on. Now the things that are pending are ingress, role-based access control, and Istio. Istio is something which is external, which is not part of Kubernetes, but I'll try to include Istio a little bit, not too much. Okay, so what we have done, so we have discussed, then what did we do with those components? First of all, we created a code. We created a very basic code and then created an image out of that code. So this is the Docker world. We created a Docker image and then we put the image in a Docker repository. We used Docker Hub, but we could have used AWS ECR or Google Cloud's Google Container Registry. Any one of them would have been fine. Then we did something. We had a namespace and we created something called deployment. And when you create deployment, it takes care of the replica set pods and the application container. And this deployment pulls image from this Docker repository. The image is of this code. So basically this code is pulled and the executable version of the code is pulled and executed inside of the deployment as pods, which is called an application container. And then we used service to expose this application to the outside world. We have done the same thing for another namespace also. Now, if we want to have communication between the deployments or services, we use something called kubedns, and kubedns can be used to communicate across various services using the service name. Now, there's a demarcation. So the left hand side of this line is the Docker world, and we did it on our personal computer. We created the code, we uploaded the image, so on and so forth. Anything from here, this line towards the right hand side, is the Kubernetes world. So we have done a mix and match of both. The container runtime, which is Docker, we saw very basics of Docker, and then we went ahead and created Kubernetes objects to deploy the application which are in Docker in a Kubernetes cluster. So that's all we have discussed, and let's proceed further from here.